Now that we have become more familiar with this shoebox model, I think it's time to reapproach a subject that we only talked about in passing, and that is the subject of adjacencies. If you recall in the previous video, we set one wall adjacent to exterior so that we only have that one wall inside our energy model, and then try to replicate the calculations that F280 does for this wall. The adjacent to field defines what goes in the energy model and in what fashion. That's why we consider it to be a very important field. We try to show it somewhere at the top so that you are always able to review it. Today I want to focus on a more detailed example and some variations to see how the adjacencies can be defined for various scenarios. In this case, we have our cabin on the ground. Let's assume that this is a level grade. So we have a slab on grade on the soil, and then we have this sloped roof. And we want to create a model that's reflecting these conditions. I would like to start from the bottom. When I select my floor, I see different adjacent to options. Exterior, interior, unheated, and soil. Exterior is for a situation where I have an exposed floor, or you may know it as cantilevered floor, where a part of the building is extending and it's interfacing with the outdoor air. Interior floors are such as the floors that are over another story of the home, another heated space of the home. Unheated floor is somewhere that's maybe over a garage, and soil is the option I'm currently looking for, because as you see, my floor here is adjacent to soil. Essentially, the other side of what I'm seeing here is supposed to be soil. The moment that I select adjacent to soil, I see new options showing up, such as the slab construction. Naturally, because there will be heat transfer based on my adjacent to choice, Studio wants to know what kind of R value this surface may have so that it can calculate the right heat loss and heat gain for it. Then we have the foundation type. The foundation type is crawl space, slab on grade, or a slab below grade. Crawl space is a situation where you have a small gap between the floor of your building and the foundation. And this crawl space, if I select it, you see that more options of that is going to show up. We want to know what the wall of that crawl space is, what the floor is, what the height of the crawl space is, and whether it's heated, it's open to the elements, or it's covered but also not heated. So these are the three options: heated, open, and vented. The other option we have for foundation is slab on grade, which better reflects what we are seeing in this reference picture. The slab on grade here is simply interfacing with the rest of the soil. So with that out of the way, I can focus on my walls. Last time I used this components pane to select the walls, but I'm going to select somewhere empty on the screen to deselect my previous selections. And this time I'm going to use the multi-select tool. So I'm gonna click on this wall and then I'm gonna hold the shift key, or I could access the multi-select tool here. Holding the shift key, I'm going to select my other components and I say adjacent to exterior. So now I have all of them showing essentially that when I'm standing inside this room, my wall is interfacing with the exterior on its other side. If this wall was shared with another unit, for example, I just would have used interior. Or if this wall was interfacing a garage or another unheated space, I would have used the unheated option. So exterior, it is based on this reference picture, which doesn't have anything around it. Now let's talk about the roof. Here I see a sloped roof, which is unlike what we did in a previous video where we created a flat roof. In this case, I have this triangular or prism shaped like space at the top. And depending on whether this is an attic or a vaulted ceiling, a few things may be different. Let's think about the attic. The attic is very simple, much simpler than the vaulted ceiling. In an attic situation, I have my insulation on a flat surface, and then I have an attic space. For some people, this may get a little confusing. So when I select my ceiling, you may be asking what is the right adjacent to if I'm having an attic. Now, similar to crawl space, we don't really think about only one part of the crawl space. We are thinking about the whole crawl space, and we are thinking that the whole crawl space is interfacing with the soil. Therefore, we say adjacent to soil. Same goes for the attic. We're not thinking about only the ceiling. We are talking about what is on the other side of the attic, and that is the exterior. So my adjacent to is in the exterior. And you may have noticed that my issues pane also had an issue, which was the ceiling was missing, and now it doesn't because I set my ceiling to exterior. So now all of my surfaces are complete. When I select the attic type, I'm asked what my construction is, and I select something there, and that's the end of it. Now let's talk about vaulted ceilings. Vaulted ceilings are a situation where you have the insulation across this sloped line. When you are in this room and you look up, you will see a sloped ceiling that is on the same trajectory as the rest of the roof. So there are a few considerations here. The first thing is that the area of my roof or ceiling in this example is larger than just the area that was on the attic, and that's basic trigonometry, meaning that more surfaces needed to create this prism-like shape than when there was only a flat surface. So I have to keep that in mind when I want to create a vaulted ceiling. I may have to adjust this width and length numbers a little bit to just show a larger number. There is also another thing I have to do, and it's that I have to account for the extra airspace that is under this vaulted ceiling. And to do that, I can easily go to my table view, and I can go to my room. You will notice that the volume has a pen icon here, meaning that it's editable. So I can just add that extra airspace to this room, add it to the volume of my room, and that's how it can get accounted for. But here I just want to have an attic roof, which is easier to implement. And when I have done my attic, so I have gone with foundation, walls, windows, doors, and then the ceiling. And in my table view, if I review it, I will notice that everything seems to be in place. So now I have done my work and I'm ready to simulate. Now let's look at the variation of this building in which the grade is not flat. It's more like this little cabin is a walkout, and the slope of the soil is causing part of it to be under the grade and part of it to be just sitting flush. How would I model this? When I was talking about the foundation or the floor adjacent to soil, there was one option I didn't discuss, and that was a slab below grade. But it does seem to be very fitting for this scenario, because we have a slab here, and as you can imagine, this is extending below the grade, which is this sloped soil. So slope causes the slab below grade to be the right option. But as soon as I select slab below grade, I notice an issue pops up, which is an error this time. It's not a warning, and errors mean that with them the simulation cannot go through. And that's why the simulate button is grayed out. So let me press the basement error, and it tells me that my basement definition is essentially incomplete. Because if I have a slab below grade, I also need to have a wall that's partially below soil. As you see in this picture, that's just how physics work. So I have to add a wall, at least one wall set to adjacent to soil. And this is where another tip about adjacencies comes into play. In a wall, as you see, we have adjacent to exterior, interior, unheated, and soil option, similar to what we talked about for the floor. But one thing to keep in mind is that adjacent to soil, it means whether it's only partially adjacent to soil or fully adjacent to soil. When you select adjacent to soil for the wall, as the reference picture shows, there is a part of this wall is adjacent to soil. We just have to specify to the software how much we are talking. And there are some options here that we can go over them to make that happen. To cut our work in half, I'm just going to shift select this other wall as well, because as you see in the reference picture, they are very similar in terms of how the grade works around them. So I will just select adjacent to soil for this one as well. And now I have to answer a few things. Pony wall is the kind of wall that they may have in a building on top of the foundation wall, just to make construction a little bit easier. Let's assume that we have a pony wall here and that's insulated 2x6. Then let's assume that our low grade construction is just rigid insulation with concrete. So I set that option 2. Now here is the interesting bit, which tells the software how much of this wall is adjacent to soil and how much of it is adjacent to exterior. It could be that all of it is adjacent to soil, but as I mentioned, the adjacent to soil, it means either partially or full, and this is the input that can define that. Let's just assume that on average, based on this reference picture, only 2 feet of this wall is below soil. So I would press 2 here to say 2 feet. And then let's assume that the rest of this 9-foot wall is pony wall. So I'm just going to put the number 7 here. And with that, I have defined my below grade walls, except for the one at the back. As you can imagine, this slope is coming up on the grade, and at some point just this wall is going to be deep below grade, and we can specify the same thing here. So we can say adjacent to soil. Perhaps let's say this one is 4 feet below soil, and I'm going to do the same with the constructions. And then for pony wall height, I am just going to say this one is 5 feet of pony wall. Now I will notice that my issues is not present anymore. That means the issue is resolved. For the foundation, I also like to do one more thing, and that is to check the table view. Specifically for foundations, it's always good to check table view before finishing up your work, just to make sure nothing is missed. Here I can see that Studio has picked up the right numbers for this slab below grade foundation. And you can see the pony wall height and the depth below grade of the wall as well. So Studio has used my inputs to create a kind of foundation that can be used in F2AD simulation. And I can again press simulate, and I can get my results. So think about those adjacencies depending on what surfaces you have in your project, and use the various options to define whether the heat is transferring through the wall into the soil, into an unheated space, into the exterior or not, or whether it's an interior one. So with this lesson, I'm happy to tell you that you have enough knowledge to focus on a whole house project. We have a new series about it, and I will see you there.